By using our ARGO AWP solution, the project information needed by commissioning flows from engineering, procurement, construction, and into the commissioning software automatically. This reduces the data load time dramatically, from weeks/months to hours/days, depending on the size of the project. You can see the time and cost savings in this slide, which is based on an actual $2 billion oil/gas project I was part of. If we would have had the Argo solution available to us at the time, then our time and cost reduction would have been incredible. $1.2 million saved, and 42 weeks not spent prepping the data. The values shown are assuming you adhere to the AWP principles from the start of the project. Even if your project is too far past the contracts/engineering phase and you are pivoting to our solution midstream, you will still gain tremendous savings with all the data being connected between the phases and flowing into commissioning. For the commissioning team, to be able to see the day-to-day progress of construction and to be able to plan ahead and pivot before issues come up, that's huge. A side effect of everyone working out of the same software with the same data set, you inherently develop a team mindset. You eliminate data redundancy, and you also eliminate data discrepancies. A simple example, a pressure transmitter with tag number PT7001 versus PT-7001. The simplest thing like a dash can cause unexpected issues if your data is siloed and in separate systems. Without our solution, the commissioning team is performing daily walkdowns of the upcoming subsystems, attending construction meetings, and meeting individually with the construction team to assess the condition of the upcoming subsystem. Reports like the Skyline report are essential and still necessary, but they do not provide insight into the construction progress. They're just a static view of what needs to be done. By using our unified solution, the majority of these tasks become simple data interrogations with reports like this subsystem readiness report. Now, the interface time between construction and commissioning becomes about resolving any roadblocks that were discovered with these reports. A much more efficient use of time. In this example, we see an upcoming subsystem turnover, the current construction progress, and any outstanding issues. For the 700-010 subsystem, there are 3 tags that are not fully installed and they're shown in red here. We can switch over to the model view now and isolate these tags. As a turnover coordinator, we already know the 3 tags we need to discuss, where they are in the facility, and how far along they are in the construction process. This means our meeting with the construction counterpart is quick and direct, and we can both get back to work. This is a two-way data flow, so in addition to seeing the commissioning status in Tracker Check, the information is also pulled back into Unifier and displayed in the model for near real-time visualizations of the commissioning status, which is visible to construction and to the client. From this slide, you can see the tremendous costs associated with communication issues on projects and how streamlining and connecting to a single data source will help mitigate these risks, which will help drive down costs. In the end, this is the biggest benefit with a consolidated package and the driving force behind our decision to unify our products. Lower costs, head off problems before they start, common data, repeatable workflows, and a team environment working towards a common goal, all of which de-risk the project for the owner, which is a win for everyone involved. Now let's take a look at the commissioning data from both the AI and model perspectives. Let's start by getting a high-level view of commissioning progress across the project. We can ask the AI, can you give us the stacked bar chart of IBOM grouped by commissioning system, commissioning subsystem, and commissioning status? This gives us a clear view of how work is distributed and where we currently stand across the different subsystems. Now let's focus on a specific subsystem to understand this in more detail. We ask the AI to give us the list of IWPs, their forecasts, and the actual days associated with subsystem 700-010. Here we can see all the work packages linked to this subsystem, including their planned and actual timelines. Now let's look at the model for the same subsystem. We click on the Commissioning tab and select the system. Once we select the system, it highlights only the materials associated with that system. Now let's select the subsystem. Let's zoom in a bit. As we can see, the different colors represent different statuses. Now let's look at the planned schedule for this subsystem. We ask the AI to give us the planned start and completion date of the subsystem. This gives us the baseline against which we measure performance. Now let's check how we are performing against that plan by asking the AI how many days of delay are in the commissioning subsystem, along with all the related columns. As we can see, the planned start for this subsystem is 4th of March 2025, and the latest IWP completion associated with the subsystem is 3rd March 2025, so we are on track. There is no delay. Now let's take a look at another subsystem within the system. As we can see, none of the materials have been installed yet. Now let's ask the AI the same question, but for this subsystem, which is 70008. As we can see, the planned start for this subsystem is 20th March 2025, and the latest IWP completion associated with it is 9th April 2025. That means we have 20 days of delay. This gives us an immediate view of schedule performance and highlights where attention is needed. What we have seen here is how the AI can quickly move from a high-level overview to detailed analysis. The 3D model adds clear visual context, helping teams make faster and more informed decisions. This is one of the most powerful features of our ARGO AWP solution.